So the purpose of this video is effectively to either review or to teach the unit circle, depending on where you're coming from, whether you've seen this before and you need a refresher, whether you've never seen this before. I'm going to try and make sense of this. So the first thing I need to say is that I'm not going to be using degrees for angles at all. So I know we all know there are 360 degrees in a circle, and that's fantastic. But for the purpose of calculus, I don't really care about degrees. I do everything in radians. And so what you really need to know is that in an entire circle, going from start all the way around to finish, it's less that it has 360 degrees and more that it has 2 pi of something that are called radians. Right? And I want to briefly cover where that comes from. I don't want to spend too long on that, but I'll cover a little bit of it. The short of it is it's called the unit circle because the radius of this circle is 1, right? Well, if the radius of the circle is 1, then the circumference of the circle would be 2 pi times the radius, which is 1. In other words, the circumference of this unit circle is 2 pi, right? So, and the unit circle here starts out at an angle of 0. Now, that could be 0 degrees, or it could be 0 radians, but in either case, you're talking about an angle that sort of starts and stops in the same place. So if I were to ask you on the unit circle where 90 degrees is, you'd say, well, if this is 0, then 90 degrees would be straight up from that because this is making a 90-degree angle, right? But like I said, I don't want to do anything with radians at all. The idea is simply that we understand that passing through this amount, draws the angle of 90 degrees. So what is that in radians, right? The first part of this lesson about the unit circle has to be us understanding radians and figuring out where they are. If you've got a handle on that, you can probably skip forward a few minutes in the video. But the short of it is, the way I think of it is I think about this all as fractions, and I know that's going to upset some of you, but bear with me for a minute. If this is 0, and if all the way around the entire circle is 2 pi, so this angle here again is 2 pi, then halfway around the circle, going from here all the way over to here, this angle here would then be pi, right? And if the path from 0 all the way to here is pi, then it makes sense that if I were to stop at the halfway point up here, I would be in an angle called pi over 2, half of pi. I mean, and I hope you recognize that when we write pi over 2, that effectively means 1/2 times pi. It effectively means there was pi, we went half that far. Right? Heck, I could continue that argument and say, well, if that's pi over 2, then this marker here is effectively pi over 4, because this one, pi over 4, is half of pi over 2, right? And so this is the idea of where these things are going to come from. So in this first slide, I sort of want to show you the locations of all of the over 4 locations. And so again, I really think about all this stuff as fractions, and I know we don't like fractions, but if you think about this top arc as being 1 full pi, then it makes sense that this is 1/4 of pi, hence pi over 4. This is 2/4 of pi, in other words, half of pi. If I went 1/4, 2/4, this would be 3/4 of pi, or 3 pi over 4, right? And when I got all the way around here, I'd be at 4 pi over 4. I would have 4/4 of pi, right? As I continue around, if this is 4/4, then this angle here is 5 pi over 4. When I get down to this angle, I would be at 6 pi over 4, but that reduces to 3 pi over 2. And the last one here, if this was 5 pi over 4, 6 pi over 4, this would be 7 pi over 4. And then eventually we get back up to here, which is 8 pi over 4, in other words, 2 pi. So those were all of the pi over 4s. And there are sort of 2 categories. There's the pi over 4 category, and then there's the pi over 3 and pi over 6 category. And I'm going to sort of lump those together because I really feel like those kind of go hand in hand, right? The same deal, I'm going to use the same argument, right? If this entire thing is pi, then imagine going 1/6 of that. Imagine that you're sort of building in 1, 2, 3, 4, 5, 6 arcs of pi. If you were to do that, you could locate, well, This is the first pi over 6. This is the second pi over 6, but 2 pi over 6 reduces to pi over 3. Right? So we went 1 pi over 6, 2 pi over 6. The next would be 3 pi over 6, but 3 pi over 6 reduces to pi over 2. Then we get 4 pi over 6. That reduces to 2 pi over 3. Here is 5 pi over 6. Here we get back to 6 pi over 6. Continuing now, one more sixth would put you at 7 pi over 6. One more would put you at 8 pi over 6, which reduces to 4 pi over 3. So this is 7 pi over 6, 8 pi over 6. This is 9 pi over 6, but that'll reduce to 3 halves. This one here is 10 pi over 6, which reduces to 5 pi over 3. And this one here, if this was 10 pi over 6, we get 11 pi over 6 here. Finally, getting all the way back around here, this would be 12 pi over 6, which of course reduces to 2 pi. So that was sort of a long intro to us getting the angle measurements, but this is where the whole thing starts. You have to be able to locate those values. And more than that, I know a lot of times this is taught from the perspective of just memorize where they are, and that's good and important, but I feel like trying to memorize these, what are there? More than 12. I think there's 16 values. I don't know. I feel like trying to memorize them as opposed to being able to locate them through some form of logic is just... I feel like memorization is going to be slower until you really, really, really get the hang of it. So this is where the locations are, right? Then that's all well and good. In the next slide, I want to start talking about how we actually evaluate unit circle values. So I'm going to get into that next. So here I have this unmarked unit circle, right? The important thing to note about evaluating functions, especially evaluating functions like the sine of something or the cosine of something, is that in essence there are really 5 key values. Right? Those 5 key values are 0, a half, the square root of 2 over 2, the square root of 3 over 2, and 1. Right? And with the method that I use for the unit circle, the idea is if you can memorize these 5 numbers and have a way of finding angles around the unit circle, then we're going to be fine. Right? So the one other thing that you need to know before we get started into any of this is that you need to know that the sine of a value, and I sort of realized that I should have gone with theta for these things instead of x. I think it's too late for me to erase them. I should have gone with the sine of theta and the cosine of theta. Pardon that terrible, terrible drawing. Oh well. Hopefully you get the idea. That's sine of theta and cosine of theta. The key with the sine of theta is that sine is always related to the y value, and cosine is always related to the x value. So as I'm referring to things in this unit circle, sine is always going to be y, cosine is always going to be x. Right? So I'm going to sort of just jump straight into an example here. Suppose that I were to ask you, what is the sine of pi over 3? Right? And in the process that I use for this, I suppose I would say that there are steps. Step 1 is basically to locate the angle. Right? So the first step is, where is pi over 3? Right? Now again, my brain, the way that I construct this is I say, well, I know this is pi, so if I were to split that into 3 pieces, this would be 1 pi over 3, this would be 2 pi over 3, this would be 3 pi over 3. It's like, here's the first slice of pi, here's the second slice of pi, here's the third slice of pi. So I understand that this angle here is pi over 3, right? So we locate the angle, right? Step 2 is to sort of mentally draw the triangle, right? And what I mean is from this point, drop down to the x-axis, drop over, and recognize that you've made a right triangle, right? Once you've got that picture, step 3 is to basically choose the side. And what do I mean by that? I basically mean choose the side, either the x side or the y side, right? In this case, because I'm looking for sine, I said up here that sine was going to be the y-coordinate. So what you're effectively looking at is you're saying that the sine of pi over 3 is this height, right? The answer to this question of what the sine of pi over 3 is nothing more complicated than what the height of this side is, right? Well, given my 5 options, it's sort of like 1 is reserved for things that use the entire length of 1. 0 is clearly reserved for things that are 0. And then 1/2, root 2 over 2, and root 3 over 2 are basically the small, medium, and large values, right? Pi over 3, if you think about the other angles, that was pi over 3, this was pi over 6, this was pi over 4. Notice that pi over 3 is sort of the highest of those 3 values. Because of that, the sine of pi over 3 is the largest of the values. It's the square root of 3 over 2. Right? I'm out of space here, so I'm going to have to scroll up before we look at another one. But that's the idea of finding the sine of pi over 3. So let me move us up here. Let's take a look at another example. Suppose that I asked you for the cosine of, let's see here, let's do the cosine of 3 pi over 4. Right? Now I don't have an official unit circle this time, so I'll just draw one. There we go. If yours is anywhere near that good, understand that you're going to be fine, right? So step 1 was, where is this angle? Where is 3 pi over 4? Well, 3 pi over 4, if you think about cutting pi into fourths, this is 1 pi over 4, this is 2 pi over 4, this is 3 pi over 4. So the angle I'm looking at is right here, 3 pi over 4. Next step is I draw my triangle. From here, I drop down to the x-axis, I draw over and up. That's my right triangle, right? Next step is that because I'm looking at cosine, I know I'm looking for this x value, right? So now, this all boils down to me figuring out what that x value is. And remember, there are only 5 options. 0, 1/2, root 2 over 2, root 3 over 2, and 1, right? So the question is, which one of those is it going to be, right? We already know it's not 1, because it's not all the way up or all the way over. It's not 0, because it exists. So your choices are, is it the small one, the medium one, or the large one, right? Well, because 3 pi over 4 is in the middle of the 3 angles that are on this side, this would be 2 pi over 3, this would be 5 pi over 6. The pi over 4 is in the middle, I'm going to use the middle value. This cosine is going to be the square root of 2 over 2. And the catch is, because this x went backward, this cosine is going to be negative. Right? And there it is. The cosine of 3 pi over 4 is the negative square root of 2 over 2. With this method of doing the unit circle, there really isn't any need for like memorization of tons and tons and tons of things. All it requires is that you be able to quickly pinpoint an angle on the unit circle and then sort of calculate what the angle is going to be from there, right? Let me do one more example of this, and then I'll probably cut this video off and I'll make another video of just examples of this, right? So one more example. So suppose I asked you for the sine of 3 pi over 2. Right? So if you're following along at home and you want to test yourself on this, try this one out. The first thing you should do is you should sort of, either on your paper or at least mentally, draw a unit circle and then follow the steps I listed before. So step 1, where is 3 pi over 2? 3 pi over 2 is straight down, right? 3 pi over 2 is down here. So the next step is supposed to be that you draw a triangle. And the problem is I can't really draw a triangle. Like if I were to draw a triangle, it would be a silly triangle that sort of goes down this way and then goes straight back up to the x-axis and doesn't even get a chance to go side to side, right? So I don't really have a triangle. So the question here is, okay, so how do I do this thing, right? Well, remember, the sine is supposed to be the y coordinate. It's supposed to be the y component of this quote-unquote triangle. Well, I don't have a triangle, but I can tell what the y component is. The y component, again, given my list of options, given my options of 0, 1/2, root 2 over 2, root 3 over 2, and 1, this y component is the whole radius of 1, so the sine will be 1. But again, because that sine is going downward in the negative direction, it's going to be negative 1. The last example I would ask, and I'll do this one in the same place to save some room. What if I asked about the cosine of pi over 2? Right? So first of all, where is pi over 2? Pi over 2 is up top. It's up here. And again, I'm in this sticky situation where I can't actually draw a triangle. But that's okay. I just remember that the cosine is supposed to be the x value, the x coordinate. Well, this triangle doesn't really have a sideways x component. Because it doesn't exist, I'm going to choose the value of 0. The cosine of pi over 2 is 0. Right? So that gives you a quick overview of how the unit circle works. I know this video was longer than I wanted it to be, but if you've never seen the unit circle before, I hope this helps. I will be making a follow-up video where I go into some of the more advanced trig functions for this. So I'll see you in that video or in whatever you decide to watch next.